This should be a simple introduction for you, even if you've never seen a sensor before or never been in automation before. I hope this crash course in sensor types and terminology helps you get comfortable and feeling good about understanding some basics of sensors and automation. So let's get started. Really the goal here is to look towards people with experience like new to factory automation, people in a new job, new career, new assignment. Maybe you're a student or an educator or a community partner who works with manufacturers, but you're not super familiar with automation. Or maybe you work in a department in manufacturing that doesn't really touch the technology, like purchasing or a manager of technicians or something like that. So the idea here is to give you some basics so you know what people are talking about and it makes sense to you. So real fast, I'm going to jump over to the poll. It looks like we have some people who are not familiar at all. We have a nice distribution of people who use sensors every day, all the way to people who are not familiar at all. So, and everything in between. So we have a really nice distribution of people. If you're an expert out there and I say something that you have an opinion on, definitely put it in the chat and we'll respond to it as we go. So moving on, I always like to start because I have people who are not familiar with sensors or automation. I always like to start with how a machine works. And I always like to start with, do you have a human body? If you have a human body, you actually have a wonderful machine and a great example and a great thing to relate to. So you have senses, right? You have sight and taste and touch and smell and hearing. Oh, there we go. And you have those senses, and they collect inputs from the world around you. They send them through your nerves, up your nerves, into your brain, and your brain looks in a big lookup table and tells your body what to do. So if you touch a hot stove, what happens, right? A signal goes up your arm, goes to your brain goes ah, and it sends a signal back down to your muscles to lift your hand away. It sends a signal to your vocal cords to yell ah. And so that's exactly like how a machine works. We have sensors inside the machine. The sensors send signals back to what's called the controller, or you might hear PLC, programmable logic controller, or PAC, programmable automation controller. And then you have actuators. You have valves and solenoids and servos and all kinds of actuators, the outputs of the machine. So you have inputs just like your senses on your body, and you have outputs just like the muscles and your voice. So your body works very similar to a machine, and you can think of it that way when you're looking at technology. Today, we're going to talk about automation sensing basics. We're going to talk about some sensing technology principles. And at the very end, I'm going to give you some ideas for selecting the right sensor technology for your application. But first, we're going to start with automation sensing basics. So the first place I always like to start is there are different types of sensors, and this part matters a little bit. You hear discrete or analog or digital, and this matters. And the easiest way to relate to that is really through a light switch. You know, we all interface with these kinds of devices all the time. And so a discrete device is your simple on-off switch, right? Is it on? Is it off? Is it on? Is it off? And that's very discrete, on or off, right? And that's very simple. And then like maybe in your dining room you have an adjustable to be able to set some mood lighting, right? And so you can vary it by moving that up and down. And so an analog sensor is very similar. It provides that kind of analog position, which is easy to relate to with like a light bulb in your dining room going up and down. And then last but not least, if you're like me, you maybe have some home automation in your house, and you can get digital interfaces now for sensors. So you can get not only on off or variability analog measurement signals, but you can get how much current was consumed in the light switch, or the time or the temperature in the room, or other feedback from the switch than just on or off. And so that's the idea between discrete and analog and digital. They each do a different thing, and they each have different values, and they each have a different price point. But knowing those differences can help you select a sensor in the end. Next, there are two types of sensors. You can do presence sensing, or you can do measurement sensing. And so presence is looking at something like, is there a snapping turtle in this picture? Yes, there's a snapping turtle. It's right here, right? There's a snapping turtle right there. But then you could have a measurement sensor. And in the measurement sensor, you want to measure how big is that snapping turtle, right? How big is that snapping turtle? And so this is a silly example, but an example of the difference between is something there and how big is that, or where physically is it? You could use a sensor, how far down the log is that, right, to do a measurement. So when we think about sensing, we think about presence sensing, is it there or not? Or we talk about measurement sensing, where we actually measure or position something. Next, almost all automation sensors, there's a lot of different voltages, but in general, your wall in your house where you plug your vacuum cleaner in, that's 120 volts AC in the United States. There's lots of different voltages around the world, right? But we're talking about AC current there. To make it easier to work with in automation, we actually use 24 volts DC. It's a little bit safer at lower currents. So we use 24 volts DC. That's the most common, but you can also encounter things like 5 volts and 12 volts and 48 volts. Those are common, but the most common in North America and in EMEA is really 24 volts DC. And so when you're looking for devices, you're looking for mostly sensors with 24 volts DC if you're doing industrial automation. And each sensor has basically three connections. You have the 24 volts, which sometimes just called the plus. You have the 0 volts, which is sometimes the minus, which is just like the plug on your lamp or the plug on your vacuum cleaner. And then you have the signal. And so the signal is what's going back to the controller. The signal is the data that's coming from the sensor itself. A lot of people talk about PNP versus NPN. This is just a logic thing, and in North America, most people want PNP unless specifically specified. It is common in Asian transplants in North America to encounter an NPN, or there's another type of logic called two-wire. But the most common thing that you'll encounter, and the most stocked thing you'll encounter in the United States and in North America in general, is what's called PNP. And all that means is when the sensor turns on, it brings the 24 volts to the load. It sends a 24 volt signal. So PNP brings positive to the load, but you don't really need to know that every day unless you're really in the details of the electronics. Just know that you're probably looking for PNP if that's a question that you get asked. Next, there's some other logic that you have to think about. Is it normally open? So like a light switch in your house is normally open, right? The light's off until you come over and you turn it on, then that turns it on, you close the circuit and it turns on the light. So a light switch is a good thing to think about as normally open. This is the most common as well, because if something's there, you want it to turn on. That's pretty common for a sensor. Then there's also something called normally closed. There are applications where that's necessary, and we won't go into those today. But think about it like your circuit breaker in your house. You want that normally closed so that there's power in your house. But if something happens, you want it to open. And so if something happens, it opens a circuit breaker in your house, and a light switch in your house. You want the light turned on when you're there. That's normally open, and that's the most common. And sometimes you'll see complementary. It has both signals inside the sensor. The other thing to know is there are basics for the electrical connectors. The most common electrical connector is an M12 connector, followed by the M8 connector, and they have the color code brown, white, blue, black. It's an IEC standard, and it's very, very common, and there's the functionality there. So the most common electrical statistics when you're trying to choose an automation sensor is you're going to find a discrete presence sensor with 24 volt power, PNP, normally open, and an M12 connector with 3 pins. And that's the most common. Before you pick any type of sensing technology, that's probably the most common thing you're going to encounter, unless inside your facility there's a specific requirement. So we're going to dive into the sensing technology principles. First is the inductive sensor. The inductive sensor uses something called an eddy current. It's just a special magnetic field, and it's used to detect ferrous metal steel targets. And the typical distances of these sensors pretty small. You're only talking about 2 inches. So you have a sensor like this, you're only talking a few millimeters beyond the sensor up to 2 inches max, but typically just a few millimeters. These are used for applications like, is something there or not? Is a linkage or a piece of a machine moving in front of it? Is the machine down or is the machine up? So it's just looking typically on, off. Is something there? Is it seated? Is a part there? So we sell these mostly into automotive, into metalworking, and to stamping and welding, but they're also used on conveyors and many different places, just looking for, is metal excuse me, are metal parts present or not. Some things to know about inductive sensors is the size of the target matters to the size of the sensor. You want a target that's bigger than the sensor face. If you have a tiny target like this, that can be a problem with detecting. The target material matters. So if you have copper, there's something called a correction factor, and so metals with less ferrous properties like copper, they have to be much closer to the sensor to be detected, unless you use something like a factor one, which is a special type of inductive sensor. And then the target approach matters. So if you're coming from the side of the sensor, if I have my sensor here and you're coming from the side, that matters. You have to be a little bit closer to the sensor versus when you come from far away. So there's different things to know about the inductive sensor and how they're applied. Capacitive sensor is the next technology. This sensing principle uses capacitance density of a material. So think of things like steel's pretty dense, wood's kind of in the middle, and foam is really light. Typical targets for this are things like plastics and wood and liquids. A lot of liquids. The typical distances are very short. It's using a field. Basically, it's taking a capacitor, if you know electronics, and opening it up, and then using the material that's in front of it to detect it. The component present or seated is a type of application. So something there like the picture on the right, or fluid material level. Very, very common to see a capacitive sensor used for, is a tank full or is a tank empty? And that's a very common application for capacitive sensors. Some things that you need to know about capacitive sensors: density, I already mentioned, can be tricky. A foam object can be, if it doesn't have much density, can maybe be tricky. And you can actually false trip a sensor if maybe your target's supposed to be wood, but someone tapes a nickel onto it. The nickel is more dense, so it can fool the sensor that the object's not there. So it's important to set up the application in a way that you're detecting the proper object. What is cool about a capacitive sensor is it can see through things. So like I've got a mac and cheese box here. I can actually use a capacitive sensor to see through the wall of the package, ignore the noodles, and know, is the cheese packet inside or not? And I think that's really cool. Or in a tank with liquid in it, we can see through a non-conductive wall like a plastic tank, and we can see the fluid inside the tank without actually penetrating the wall. There is a special technology, a hybrid capacitive technology that Balluff has, that ignores problems with foaming and filming. So if you think of like a beer with a big head on it, or a soda with a lot of foam at the top, you could have some issues with that, or blood, I know, foams. Or peanut butter sticks to the side and you have filming, any kind of foaming or filming. There's hybrid capacitive technologies that can handle that. Next is the photoelectric sensor. This sensing principle uses light. Its typical target is plastic, metal. We like opaque. You can detect clear objects with special versions. These distances can be huge. Depending on the technology specifically you're using, you can have short distances up to 60 plus meters, 200 feet or something. So photoelectric sensors are used similarly for like component presence, like you can see vials there on the right, or on the left, measurement or position, where we're actually using an analog laser. So something that's measuring position to detect into a cardboard box. You can see in the bottom left-hand corner, the sensors are in the top, the box is in the bottom, and we're actually shooting into the box to determine how deep into the box does the robot need to go to actually determine the position of the robot. So there's lots of photoelectric sensing modes. What I'm going to tell you is each one requires an emitter and a receiver. The most reliable technology is what's called through beam. The emitter's on one side, the receiver's on the other side. And when an object breaks the light, dark on, it turns on the sensor signal. And so retroreflective works similarly, except for it uses a reflector on the opposite side. And then diffuse has the emitter and receiver inside one housing, and it uses the reflectivity of the object to actually detect. So through beam is the most reliable because it has an emitter on one side, a receiver on the other, and when you break the beam, it works and it detects the object, where diffuse actually relies on the reflection of the material. And then there's something called background suppression. It's a type of diffuse sensor that allows us to ignore things that are in the background, which can be really valuable for different applications. Some things to know about photoelectric sensors: various light applications. There's tons and tons here, and different emitters and different types of light. There's lasers and infrared and color detection and UV lights and all different kinds of of lights to do different applications to detect different things. And so photoelectrics are really versatile and there's lots of different options. And so it can sometimes feel a little overwhelming depending on what you're trying to do. But we're going to talk about how to select sensors in just a little bit. The next thing you have to think about is target materials and what's the effect of the target material. If you have clear glass, you really have to have a special photoelectric sensor to detect that, or maybe a capacitive sensor. And anything that's like super matte black, like maybe my shirt here or a piece of black fabric, might have trouble with some photoelectric sensors being detected because if you use diffuse, you're relying on the reflectivity of the object, remember, and black, of course, absorbs light. So you have to make sure you test things when you're doing that. And then last but not least, what's really cool is you can use a laser. We can do time of flight, and the sensor actually shoots out the laser and looks for how much time it takes to get the light back. And based upon that, we can actually calculate with really nice precision how far the object is, and we can actually measure things down to thousands and sub-thousands. Next are two magnetic field technologies that I want to talk about. I'm going to talk about the one on the left first, and that's for pneumatic cylinders. So magnetic field sensors for pneumatic cylinders. Sometimes they're just called cylinder sensors. You might call them Hall switches or Reed switches. The technology I like to talk about is what's called solid state, and so but it does the same function as a Reed switch or a Hall effect switch. It looks for a magnet inside a pneumatic cylinder. And so as the piston moves back and forth, the sensor detects the position. So I've got a tiny little cylinder here, and you can see the cylinder can move back and forth. There are two sensors mounted right on top of it, and they give the extend and retract positions. And so that's really powerful because it allows us to know, did the cylinder do its action, right? And so just like your arm, if your brain sends a signal down to your arm, move, you want to get feedback, like your eyes provide feedback. Did my arm move to the right place? And there are senses inside your arm. Did my arm move to the right place? So same idea. And then there's linear position sensors. And these use a technology called magnetostrictive. It uses a magnet similar on the piston, but these are used in hydraulic cylinders. And so these can be a little bit different, and these can be up to 7.6 meters long. And so I don't know, that's some crazy length, 25, 26 feet or something. Magnetic field sensors, like I mentioned, are mounted in pneumatic grippers. They're mounted in pneumatic cylinders. You can see here on a welding gun on the end of a robot, you could see a magnetic cylinder to see if the cylinder extended or not. And then on the right, you can see the linear position sensors being used in a lathe here, deciding where the guide is. You could see a float here inside a tank. So a float has a magnet on it, and as the float goes up and down, we get a measurement position in the tank to know the tank level. And then here you could see some hydraulic cylinders. So the sensor's embedded inside the hydraulic cylinders, and then we get feedback on the position of the hydraulic cylinder. So there's hydraulic cylinder applications and there's pneumatic cylinder applications. So a lot of different things you can do with sensors in fluid power. The ultrasonic sensor is almost the last one I'm going to talk about. The ultrasonic sensor technology is a sensing principle of sound. So it uses sound waves. It's really fun. I meant to have one here and I can't find it. I swear it's here somewhere. The ultrasonic sensor, you can actually hear the sound of the sensor if you hold it up to your ear. It bounces the sound against the object and brings it back. The typical targets can really be anything, just like a photo eye, plastic, metal. The real trick is it can't be too thin that it doesn't return the sound waves. Typical distances, I've seen all kinds of distances of these, up to 6+ meters, 20+ feet, all the way down to short distances like 25 meters. Something to know that I think is really cool is you can actually bounce or turn the signal. So there's some cool applications that people have done where you can actually bounce the sound to get to the object and then bounce it back. If there's not a physical space to be able to mount the sensor in the way that you need to mount it, you have some options to be able to do this. Of course, you should test it before you put it into an application, but there's some neat things you can do with an ultrasonic sensor. Other sensor technologies, I can't go through them all today. There's so many sensing technologies, but you've got pressure, you've got temperature, you've got flow, so all kinds of process sensors that are out there that can give you feedback. Many times these are discrete switches, just on off, but you can also get versions with analog and measurement values in them as well as digital versions where it sends information digitally. So that idea of presence and analog analog and digital carries to most technologies. RFID isn't necessarily exactly a sensor, but RFID technology is really neat because it allows you to detect if a tag's there, read data off the tag, and you can do a lot of cool applications with RFID. You could see fork sensor there. I had one here earlier. The fork sensors are awesome because you get the most reliable through beam technology, but you don't have to align two different pieces of hardware. It's all in one housing. And lots of people carry these, not just Balluff. And then we have vision sensors. Vision seems like super high end, but vision can be very approachable as an application. And many times, if you've got 2 or 3 sensors to do an application, sometimes it's easier to do it with a vision camera. And so, smart cameras and vision sensors and vision and higher end cameras and camera systems can all be used in sensor applications as well, depending on what the application is. And then things like this is a rotary encoder down here on the bottom, or an inclination sensor up in the top. An inclination sensor gives an angle of inclination, and then even mechanical switches and many more that are out there in the market. So how do you select the right sensor technology for your application? Things you have to think about are what types of technologies are we already using in the plant? What is the sensing distance that we really need to be able to detect the object? What is the housing or form factor of the device? What are the connection types? What do I have to connect it to? Am I connecting it to a PLC or a relay or an Ethernet node? What am I connecting it to? And then, how ready are we for the application? Do we have any of the infrastructure in place for automation, or do we need to put some infrastructure in place? Do we have IO blocks or something to hook the sensor into? So 5 questions to ask when selecting a sensor. The first is, what is the target? What is the target material? What is the surface finish? And that really helps you determine what's the type of technology you need. The second is position. Is the position repeatable? How close can I get? What is the direction of movement? This helps us determine the types of technology and the sensing distance. Third is space. Is there room to mount a sensor? How much room? Can I change anything? And that really helps us determine the sensor housing form factor and also the types of technologies that we can use. Fourth is environment, and environment's important because we have to think about what hostilities will the sensor be exposed to. Will it be exposed to vibration or impact or other environmental factors like washdown or being outside? All of that matters for picking the sensor housing and the types of technologies we can use. And then fifth, and certainly not least, is the connection. Wires or connector, where does the input go? Is 24 volts nearby? It tells us, are we ready for the application? What sensor housing do we need? And what kind of connector type do we need? So when you're making the decision, there are excellent online selector tools out there. If you have the answers to those 5 questions available, using selector tools will go very smoothly. When you're in doubt and you're not sure an application will work, you should absolutely test it. Sensors are best when you hook them up and give it a try and see how repeatable it is. Maybe the first technology you thought would work didn't really work, and maybe the second or third attempt works. So it's always good to test things. And when in doubt, and last but not least, make sure you find a trusted advisor, someone who knows sensing, who's done applications, who's familiar with it. Find that trusted advisor and work with them to pick out the right sensor technologies. So additional resources, Balluff has an awesome product finder on our website. I would dare say one of the market leading product finders, one of the best interfaces. All the technical data and everything that someone needs is there, but also in the web shop, this is a great customer portal experience. You can get quotes there, you can get delivery notes there, you can do order tracking, and all kinds of information is available to you there right on the web shop. And that's a very powerful tool for every customer that Balluff has. Final resources I have, we have an excellent basics of automation site as well as basics videos available on YouTube. The links are there. We write and work on the Automation Insights blog, which is a vendor neutral discussion of automation technologies and automation basics. Definitely recommend that. And then, of course, I share a video every day talking about automation and sensor basics. Follow me on LinkedIn.